Hello friends, this video on probability part 2 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1. And that is the reason why we have the classical or theoretical approach. This is what we will study, so we'll focus on this. So since the earlier method has had disadvantage, that is the result is not consistent and it is not possible to actually perform the experiment every time, so we have the classical and theoretical approach. So here we assume that the first thing is, please assume that all the experiments have equal likely outcome. I'll explain this. This is the assumption we are making, that all the events are equal likely outcome. When I say equal likely, for example, when I say head and tail, so this is equal and this is equal. Probability of head and probability of tail is equal. All are equal likely. That is, probability of head will always be 1 by 2. Tail will always be 1 by 2. So I'm drawing a coin or from a ball, it is bag that has red, blue, yellow, white, and let's suppose pink and orange also. 6 color. So in that case, the probability of red will always be 1 by 1, 2, 3, 4, 5, 6. 1 by 6. Probability of blue will always be 1 by 6. This is the assumption actually, that all the experiments have equal likely event outcomes. That is, I mean, in the earlier case, if you see in the earlier method, you have to actually take out red and see what's the probability it comes. Sometimes it comes 1 by 6, sometimes it comes different also. But in this case, it is assumed that whatever be the scenario, the probability of red always be 1 by 6. Also, the same formula here also for probability of event is nothing but probability, the number of favorable outcome by all possible outcomes. Correct? Outcome favorables by all possible outcomes. Also, one more thing, if you add all the probabilities of the elementary events, that should give 1. For example, probability of head plus probability of tail should give 1. If you see here, 1 by 2 plus 1 by 2 is equal to 1. Here also, probability of red ball plus probability of blue ball, if you add all this, right, 6 balls, that should become 1. If you see 1 by 6 plus 1 by 6, 6 times, that gives 1. Also, one more thing, that is, any probability is always greater than equal to 0 or less than equal to 1. So when it is equal to 0, it means impossible, that it will never come. For example, when I say, from this set of balls, red, blue, yellow, white, pink, orange, I want to withdraw a brown ball, but there is no brown. This is black actually. There is no brown. So in that case, brown will never come. So it is 100% that 0 result will come. Correct? So it is impossible event. So when the probability of any event is 0, that means it is an impossible event. And when it is 1, that it is sure shot event. So we'll discuss all this, but just understand that the probability is always greater than equal to 0 or less than equal to 1. Let's take some example. It's a very simple example. We have to say which of the following have equally likely outcome. The first thing is, a driver attempts to start a car. The car does not start. Is it an equally likely outcome? The answer is no. Why? Because it is not universally true that it will have some fixed value. This will depend on the condition of the car. If this guy is starting a brand new BMW, the probability that it will start is 100%. Sure shot it will start. If the driver is trying to start a very old car, with this is not the battery is not charged or there is no oil, then in that case the probability that it will not start is high. Correct? Also, it depends on driver also. If the driver is very new, if he is given a good car also, he may not be able to start the car if he is not aware of how to start the car. So the driver starting the car depends on two conditions: the experience of the driver and the condition of the car. It is not independent of all these two factors. So we can say that this is not a equally likely event. Correct? The second is a player attempt to shoot a basketball. She shoots or miss the shot. Here also no. Correct. Why? Because it depends on the quality of the player. If the player is very experienced, he is very good, he will definitely 90% chance is there that he will hit the shot. If the player is very new guy, he is not even aware of basketball, the person like me, 10% chance is there that he'll hit. 90% he won't even hit. Correct? So these things depends on the quality of the player. Correct? A trial is made to answer true or false question. The answer is right or wrong. Here if you see, yeah, this is an equal likely event. Why? Because here the chances is 50-50. 50% it may be correct, 50% it may be wrong. Because there are only two options. So you have, let's suppose a question, you ask true or false, it will either be true or false. Right? Or if you attempt the question also, your answer may be correct or incorrect. There is only two options. And please note, a trial is made here. If the same question was a student answers to a question true or false, to a student answers to a true or false question, what is the probability? Is it the answer is right or wrong? Is it a equal probability event? Then in that case we can say no, because if the student is the topper, the chances that he will give correct answer is more. If the student is a backbencher or he's not that good, the chances that he may give the answer is incorrect. So in that case it depends on the quality of the student. But in this case the question clearly says it's a trial. Just a trial is made without even looking. We are just giving true or false. Then in that case it is 50-50. Correct? Because here in trial we are just blindly giving true or false. The next thing is a baby is born, is a boy or girl. Again here also it is yes. Why? Because it is independent of factor. It is a luck. Sometimes you get boy girl, sometimes you get girl. It is something which we don't have control over. We can't even modulate all this thing. We can't rig this. So in that case this is also yes. In the first two cases we can rig the event by improving or deteriorating the quality of driver or the quality of car or the quality of player. But in these two events we can't rig. India will win World Cup or not? Again this is also not a equal likely event. Why? Because it all depends how India is performing that day, which is the competitive team. There are so many factors. How is the pitch quality? There are so many factors. So India will win cup or not? This is not a equal likely event. You will pass math test or not? Again no. Why? Because in this case you are involved. Here India is involved. These people can rig. In fact you can rig the total outcome. If you perform well, in math test, you will get pass. If you don't perform well, if you don't score, if you don't practice, you may fail. So it is you who can rig the whole thing. So it is not equal likely. So here if you see only two events are not equal likely event because there is no one to rig. And the chances are 50-50. Correct? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.